Okay, so today we're going to talk about revenue versus expenses. And so we cover a couple outcomes here. You're going to be able to calculate expense and revenue equations, as well as graph these equations to find break-even points. So basically, with expenses and revenues, the total the expenses for a product is going to include sort of variable expenses as well as the sort of fixed expenses, and those can vary. Different things for different companies, but basically it costs money to make products, and so those will be included in those expenses. But it's not just related to the things that they have in terms of manufacturing. It could be shipping, marketing, all those are included in expenses. Revenue is how much money they take in, um, for selling the product. And so when you combine expenses and revenue, you can see, what you need to do to make a profit. So both expenses and revenue rely heavily on price and demand. So it's easier just to actually graph the equations and look at them graphically to see sort of what's going on. But you'll see that demand functions are linear functions. We've already talked about demand. Demand functions are linear, but revenue functions are not, because revenue functions are actually quadratic. They're squared equations, and so they're actually going to have curve to them. And parabolas, like if you remember from parabolas, they have maximums. They have vertices. So in a revenue function, the parabola's maximum or revenue maximum is actually the price at which they would make the most revenue, and it's very important to businesses. So let's talk about expense as well as revenue. So expense relates to demand. So you'll see the expense equation being equal to the quantity demanded, or QD, call it QD. But it is the variable expenses plus any fixed expenses. And revenue is the product of the price and the quantity demanded. So we use that equation R, or revenue, R equals P times Q, which is the price times the quantity demanded, or QD. And it's the money taken after the sales of a product. So today we're going to look at expenses and revenue equations as well as graph them to find break-even points. So we're going to start off with example number 1. A particular item in the Picasso Paints product line costs $7 to manufacture, but then there are some fixed costs that are $28,000. The demand function is QD equals negative 500p, remember P is price, plus 30,000, where QD is the demand given a certain price, P. So we're going to find the expense function in terms of price. So what we need to do is we'll write down the expense function, E equals 7Q, which is the price, the variable prices plus the fixed price of 28,000. So E equals 7Q plus 28,000. Now to write that in terms of price, we're going to use the other equation, which is the demand equation, because that is in terms of price. So since the expense equation has Q in it, we can substitute the Q into the QD into the Q in the expense function. So when we substitute it in there, we have 7 times parentheses negative 500p plus 30,000. And then plus the 28,000. When we distribute the 7, you get negative 3,500 plus 210,000 plus the remaining 28,000. And then when you add everything together there, you end up with an expense function that is in terms of price, and that is negative 3,500p plus 238,000. And that's writing it in terms of p. So now let's find the revenue for that particular function. Revenue is P times Q. So basically, we have to take the the P, which is price, and multiply it times our Q. Remember, Q is demand. It's actually Q sub D. So QD. QD is demand. So we're going to take P and multiply it times our Q equation. So what that looks like is P times the quantity negative 500P plus 30,000. When we distribute the P, you'll get negative 500P squared plus 30,000 P. So what you see here is what I talked about earlier. Revenue is a quadratic. Revenue is a squared equation. So in this particular answer, the revenue is a parabola. So what we can do now is graph the revenue function and figure out all kinds of information from it. So we're going to open up Desmos, and when you open up Desmos, you'll see it opens up to a regular empty graph, and you're going to plug in the revenue function, the negative 500P squared plus 30,000P. So go ahead and plug it in, negative 500P squared plus 30,000P. And after some sort of manipulating of the graph, because you do have to stretch and shrink the axis, get it to where you can see the graph, the whole thing in there, the top and the bottom sort of the parabola. And when you do that, you can see that the x-axis is the price. So you can go all the way around the curve and see where the price is. At 0, how much revenue would you have? At $5, how much revenue would you have? And at $10, $12, whatever, and so on. And how much revenue would be produced based on that price point. So the question in example 3, if we go back to Notability, says, what would the revenue be if the price was set at $25? So what you can do is go back into Desmos, put the put x equal, because x is price, so that's $25. Put in the price is $25, and hit x equals $25, and you'll see where they cross. And you click on that dot, and you'll see that the revenue at $25 is $437,500. So that's how I do it. And you could even do it for, the next question says, which price would give a better revenue, $28 or $40? So you can even go back into Desmos, plug in both 28, x equals 28, and x equals 40, and you would see that you can compare the two dots to see which one is higher. And in this case, $28 is the higher one, and that gives you a revenue of $448,000. So if we navigate back to Desmos, or sorry, to Notability, we can finish this off. So Notability, here we're going to talk about now break-even points, which is where your expenses meet your revenue. So it says, what happens when revenue equals expense? Since revenue is a quadratic and expenses is a line, there may be points where the two graphs cross, and usually there is. The 2 points where they cross show where expense and revenue are equal. So if you think about it, it's where all the things that the company has to pay for equals all the money coming in. So if you think of that, you have expenses, or what you pay for, revenues, the money coming in. Where they're both the same is where they would break even. So the company would break even when its expenses are the same as its revenue. You would just make $0. So there would be no profit. So decision makers often examine these break-even points to set appropriate prices to maximize revenue. Pricing the item too low might sell a lot of product, but you don't make a lot of revenue. Selling it too high would make a lot of money per item, but you might not sell as much. So there is a fine line as to where the price point should be to maximize revenue. So you can see on Desmos here, I've shaded shaded in the area that's above the line. Everything that's above the expense line, that's profit. Anytime your revenue goes above the expense line, so the area that's above the line, that is where you're making a profit. Your revenue's more than expenses. And anywhere that you're down below the expense line, that means that your revenue is actually less than your expenses, which means you're actually losing money. And that's between loss and profit. So we're going to make this pretty simple with the next couple of examples and look at, so example 4 says, what's happening at the graph at points A and B, and where your expense and your revenue cross, those are called break-even points. That's where revenue equals expenses and there's zero profit. Now, the second part of that question says, now why is using prices of $7.50 and $61 not the best idea for that company? Well, if you look at the break-even points, $7.50 is lower than that break-even point on the left, and $61 is more than the break-even point on the right. So it actually puts it below the line. So both of those points are not good. Those are not good price points because you would actually make less revenue than you have expenses, and therefore you will lose money. The last question says determine the break-even points for Picasso paints, product in example 1. The expense function is there. That's the linear function, and the revenue function is there. That's the quadratic. So all we need to do is go back to Desmos. So go back to Desmos and just plug those equations in. Clear any of the other equations that are already there and plug them into Desmos. And you'll see a graph that looks very similar to the one that you saw in the previous problem, where you have a quadratic and a linear graph going right through it. And where they cross are those break-even points. So once you plug them in, just tap on where they cross and the break-even points come up. Looks like that it breaks even at $8.08 as well as $58.92. So that is revenue and expenses and finding break-even points. You can scroll down. Actually, the practice is not on this particular set of notes, so just go back to Canvas and open up the worksheet there, and you'll be able to do the practices there. Your assignment, if you're doing this for an e-learning assignment, your assignment is to do the practice and submit the answers via Canvas. Thanks.